Hello, Maurits here. This will be a bit about circular motion. And say we have something moving around in a circle with a constant speed. So we have some speed to go and the same all over. And to make it move inwards, we need some kind of force pointing inward. That we previously talked about in a video. We talked about the centripetal force, and we found the equation that the force equals to the mass times the velocity square over the radius of this path, and we have some force there, which also can talk about the centripetal acceleration, and that equals to v square over r. We have to remember now that we're accelerating inwards all the time, and that's why we go in this curved path. We also have to remember that the velocity as we go around equals, as always, the distance over time. In this case, the distance is a full turn, 2 pi r, over the period, how long time it takes to make one turn. And since we know that frequency equals 1 over the period, we can also rewrite this formula as 2 pi rf. But we also know, since previously, that the angular velocity, or angular frequency, equals to 2 pi times the frequency. Remember that one full turn is 2 pi radians, and so if we do 5 turns a second, we do 2 pi times 5 radians per second, since each turn is 2 pi radians. Wait a minute, 2 pi frequency we have it over there, so we could write this as the nice formula omega r. So the velocity around the path is proportional to the angular velocity and proportional to radius. And it makes sense, right? Because if I double the radius, the circumference will also double. And so I need twice the speed to get around for a given angular velocity. We can combine these two things and say, I will say that acceleration equals to v square over r, which can be written as v square times 1 over r, right? And v we have from here, so we can do a bunch of different formulas. Let us say I will use this thing, so then I can have 2 pi r over t squared times 1 over r. That will become 4 pi square r square over t square times 1 over r, and we can cancel this r against one of those two and get the formula 4 pi square r over t square, for example. You can make other formulas from this. Okay, let's look at an example. Say we have a bike wheel and it's spinning around, and on one of the spokes going out we have a little ring, and if the wheel turns very slowly, this ring will fall down here, and then it comes up over here and slides in the middle, and then as the wheel turns over it will slide down again, and so on. But if this wheel would rotate fast enough, and the centripetal force would keep this, or actually the centrifugal force, so to speak, the tendency of this to move in a straight line will keep it out here on the rim. And we can see here, if this is rolling without sliding, the lower end would have a velocity of 0, and the middle will have some velocity of v, and the top one will have twice the speed, 2v. But now let us take a camera, so to speak, and follow the wheel, and then we can see that the wheel, this end now, will go in that direction with a velocity v. The center will stand still, and the top one will go in that direction with the velocity v. This will go up with the velocity v, and this will go down with the velocity v. It will simply spin around as we follow the wheel. And say this is a 24-inch wheel, and we have that that will be 24 times 2.54 centimeter per inch, and that will give us, if I'm not mistaken, where did the calculator go? Have it over here. So we have 24 times 2.54, and that is 61 centimeters. So the radius would be half of that, right? Oh, I need a calculator for this. So 30.5 centimeters, or 0.305 meters. So that is the radius, and now we can basically just plug everything into our formula. And what our goal was, as I said, we wanted to stay up here, which means that we need to have an acceleration such that it will withstand the force of gravity, right? So we can say, okay, our acceleration here, that is g, should be equal to our velocity square over r. In other words, v square is g times r, or the velocity equals the square root of gr. And we can plug in our numbers. Our velocity will now be square root of 9.81 times 0.305. So catch our calculator again. 9.81 times 0.305. Shift square root, shift ounce, enter. So we need a speed about 1.7 meters per second, and that will be times 3.6, and that is about 6.2 kilometers per hour. Not that fast. So at that speed, the ring will keep on the outer edge. There will be twice the down here. It will be twice the acceleration up there. It will be 0, but it just barely will keep on being on the outer rim of this curve. So that's the first introduction of this. We had made a formula, but a problem, except for the electronics things, where we can use this. Thank you.